first off, we have a circle. Here we have a radius. So everyone knows that terminology. And here we have diameter. And I can actually change my circle should I want to. Okay, now here I have my rule and my angle. So what I'm going to do is, let's have a look if we can notice anything here. I'll move that like that. Can you notice any relationship? I think it might be nice if I animate that. So look at that 59. Now it's 121. Now it's 59. Now it's 121. So I want you to get that. Yep.
Is it like half of the other side?
Yeah, let's actually get some nicer numbers. I'm going to get that angle in the centre. What about 160? Okay, to 160. And this one here's 80. So can we see a relationship between the 80 and the 60? Here I'll move it to 130 and 65. Whoops. What about 50 and not quite behaving for me, is it? I want to get 100 there. Can I find 100? No, I'm getting bigger. Smaller. There's 100 and there's 50. That's nice, isn't it? So the angle at the centre is called this angle here, is actually twice the angle at the circumference. Okay, so I'll just, I'll leave that there. Function print screen, I'll go into Paint so I can scribble all over it. So what I'm trying to show is that this here, this one, this here is the angle at the centre. That one here, okay? The angle at the centre is twice the angle at the circumference. This is the angle at the circumference. So if this is x, that's 2x. So let's try that. If I said this angle here was 30, what would this one be? 60, correct. If this angle here, if the angle, okay, so I'll draw it, there's in the centre, that's at the circumference. So if this one here was 120 degrees, what would that one be? 60, yeah. Okay, so the angle at the centre, this angle here, is 2 times this angle here. Okay, so that's a new angle rule. So that's cool. Now I'm going to try and prove it to you. So, no. Oh, that's all right. There we go. Okay, so what's my proof? Now this gets a bit tricky. My proof is easier to when I can draw all over it. What I'm saying here, if I put an extra line in there, that and that and that are what? What's special about them, those three? Yeah, you said it quietly. They are all radiuses or radii of the circle. So this length is the same as this length, is the same as that length. Is that okay? Yes? Yep. Which means that this angle and that angle must be the same. Also, because angles in a triangle, 1, 2, 3 add to 180, and angles in a straight line, this one and this one add to 180, I also know that if I add these two up, it'll be the same as this. Okay? That's actually a triangle rule that we're going to be covering. So if I've got, if I've got an isosceles triangle like that, I've got an angle there and an angle there, then these three add to 180, and these two add to 180. So this plus this has to equal that. Okay? So that same thing here, this one and this one have to be the same, they're equal to each other, and this is actually two of them. Does that make sense? So now I've proved that this angle here is a red one and a green one, and this is two red and two green. So this angle here is double that angle there. So that's the proof. Hands up who got the proof. Oh, about 5? That's all right.